If you've been with us before, you already know, guys. We don't do boring here. Today we're cutting straight to the core of what makes blockchain actually work. We're talking about consensus, mechanisms, and scalability. Let's think of it this way, guys. What's the point of a decentralized network if it can't scale or reach agreement efficiently? We're diving deep into how different blockchains solve this, of course, from PBFT and DPoS to zk-Rollups and Sidechains. Why does this matter? Because I think understanding consensus is key, guys. This is how blockchains stay secure, fast, and decentralized all at once. And if that balance isn't right, let's say that's when networks break. Before we dive in, a few house rules that you already know to keep the session smooth. Let's use the raise hand button if you want to jump in and speak. Let's drop questions in the chat anytime. We'll tackle them as we go. And let's keep it engaging. No interruptions. We're all here to learn and share insights. And we already know all of those rules already. And speaking of learning, guys, if you're here, you should definitely be getting certified too. I'm talking about the Hashgraph Hedera certification. It's still free for now. And if you haven't grabbed your spot yet, what are you waiting for? It's that simple. So now let's kick things off. Yusuf, if you're ready, let's break it down, man. Thank you.
Welcome everyone to Educational Friday. So thank you very much, Amin, for your presentation. So if you don't know me, anyone here, my name is Yusuf and I work as software engineer at Dar Blockchain, specialized in blockchain and cryptocurrencies. So as we always say, Educational Friday is a dedicated space to learn, connect, and innovate. Today we're launching a new format, so an 8-session educational journey. So you will enhance your skills, connect with community members, and grow together. If you attend all the sessions, you receive an official proof of attendance certificate from their blockchain after attending all the 8 sessions. You will be able to boost your knowledge with our structured, engaging, and beneficial educational content that awaits for you. So we can move on to the next slide, Anas. Okay, the guys. So before we begin, let's quickly complete the attendance check for session 1. Please scan the QR code displayed on the screen. This helps us keep track of participation and ensures you're recognized for attending today's session. I'll give everyone a moment to scan the QR code once, and once you've done that, we'll proceed with today's exciting content on consensus mechanisms and scalability. Also, Emin will drop the link form in the chat. So I'll give you quickly a moment, guys, to do that. While waiting for you, let's give a huge thank to Dar Blockchain and the Hashgraph Association for supporting this initiative and creating a space for education, collaboration, and innovation. And I just want to quickly remind you that Dar Blockchain is offering a free Hashgraph Association certificate supported by Hedera Technology. So it's an excellent opportunity for beginners to learn about Web3 and its applications. A common question I get asked by blockchain enthusiasts, what makes it worth my time? So it's really worth your time, guys, because first you learn the fundamentals. You'll gain a clear understanding of how blockchain and distributed ledger technologies work, with a focus on Hedera powered solutions. Also, you'll gain practical knowledge. So this course provides insights into real world use cases, helping you connect the theory to practical applications in industries like finance, gaming, and beyond. Also, you'll enhance your resume as Web3 continues to grow. Having a certificate from credible organization signals your skills and enthusiasm by for centralized technology. Finally, as Amin said, it's completely free and accessible, making it an inclusive way to explore this cutting-edge space without financial barriers. So I think we can move on to the next slide, Anas, please. Okay, guys, so once again, welcome to session 1, dedicated to exploring the core aspects of consensus mechanisms and scalability. So this is the first session of this program. We'll also focus on other blockchain and crypto aspects during this program, like tokenomics and governance, enterprise blockchain frameworks, cross-chain interoperability bridges, DeFi use cases, reward applications, blockchain data privacy and compliance, and also smart contract security and auditing. So it's a really well-structured program. But let's now focus in this session. So we'll start with a brief introduction to establish foundational concepts. Next, we'll discuss advanced consensus mechanisms, examining innovations beyond traditional proof of work and proof of stake. We'll then dive into scalability challenges, one of the biggest hurdles faced by blockchain technology today, and examine layer 2 scalability solutions, highlighting approaches designed to improve transaction throughput without compromising decentralization. Additionally, we'll explore sidechains and state chains, two promising technologies aimed at achieving faster and more efficient blockchain interactions. We'll also analyze how consensus mechanisms directly impact network performance, balancing security, decentralization, and speed. Finally, we'll touch on emerging future trends and innovation in blockchain scalability and consensus mechanisms, and conclude with potential research topics, as I usually do, to guide your future exploration and development in this dynamic field. So next slide, please. Okay, let's start with an introduction. So in this slide, we'll establish a clear understanding of consensus mechanisms, beginning with their definition. Consensus is essentially the method blockchain networks use to reach agreement on transaction validity, ensuring consistency, reliability, and trust among decentralized nodes. The purpose of consensus mechanisms is crucial. They allow blockchain networks to maintain a single shared version of the truth without relying on a central authority. They also help prevent fraud and double spending, thereby safeguarding transactional integrity. Consensus is of paramount importance for blockchain technology as it facilitates decentralization, enabling trustless interactions while maintaining the overall integrity and security of the network. From a historical context, consensus has evolved significantly, moving from basic voting mechanisms to sophisticated algorithms. Notable milestones include Bitcoin's proof of work, so we already covered that in previous sessions. Also, Ethereum's transition toward proof of stake, and further adaptations such as PBFT, practical Byzantine fault tolerance, and delegated proof of stake. To ground these concepts, let's briefly discuss a few real-world examples. Proof of work is well known for its security. Can you go back, Anas, please? And decentralization. Proof of stake, however, offers an energy efficient, scalable alternative reliant on the stake held by participant. PBFT is valued for its speed and determinism despite high communication overhead. Delegated proof of work, proof of stake offers increased efficiency and speed, although it carries some risks of potential centralization. So next slide, please. Let's now focus only on advanced consensus algorithm. So we'll dive deeper first into practical Byzantine fault tolerance, commonly known as PBFT. So if anyone here in the audience can tell me, can give me an example of a cryptocurrency that uses PBFT. So we already covered that in previous sessions. You can drop it in the chat. So anyone here knows a cryptocurrency that uses. Okay, so Fernand said Edera. Absolutely, yeah, you're right about that. Edera uses this consensus mechanism. Okay, so PBFT operates on key principles designed to achieve consensus, even when some nodes in the network are malicious or faulty. The mechanism depends on achieving majority agreement among nodes to ensure reliable block finality, allowing the network to continue functioning securely. So from a technical perspective, PBFT progresses through structured consensus rounds, specifically the prepare and the prepare and commit phases. Each step helps ensure fault tolerance and maintain strong security assumptions, even under adversarial conditions. PBFT offers significant advantages. Notably, it provides immediate and deterministic transaction finality, meaning there's no uncertainty regarding transaction completion. Additionally, it is resilient against network partitioning, allowing the system to maintain integrity even when communication disruptions occur. However, PBFT also has its limitations. It involves considerable communication overhead, limiting its scalability. Performance can decrease as more nodes join the network due to the intensive message exchanges required. In terms of real-world applications, PBFT has found significant adoption in permissioned blockchain systems, such as Hyperledger Fabric, which is widely used in enterprise settings, and also Tendermint, which underlies the Cosmos blockchain ecosystem. So understanding PBFT helps illustrate how advanced consensus mechanisms balance security, reliability, and performance in modern blockchain networks. Next slide, please. So another advanced consensus algorithm that I wanted to cover is delegated proof of stake. So this mechanism is designed for efficiency and scalability. So delegated proof of stake, or DPoS, operates through an operational mechanism where stakeholders delegate their voting power to trusted validators. These validators are responsible for managing and validating transactions, making the process faster and more efficient compared to traditional proof of stake mechanisms. In terms of stakeholders' roles, we have three primary participants. So we have first delegators, validators, and block producers. So delegators are token holders that delegate their power. And validators are trusted nodes responsible for securing the network. And block producers are selected validators who actually create new blocks. So DPoS also introduces unique economic and governance through dynamics through voting systems, also through incentives and economic motivations. Validators are incentivized to perform honestly as stakeholders can quickly withdraw their support in case of misbehavior. The primary advantages of DPoS include high transaction throughput, low latency, and exceptional energy efficiency. Key factors for scaling blockchain networks. So it performs particularly well even as the number of nodes increases, delivering good performance relative to traditional methods. However, DPoS comes with certain limitations. It poses risks related to centralization, since power tends to concentrate among a limited group of validators, potentially leading to governance vulnerabilities. Real-world applications of successful DPoS implementations include prominent blockchain platforms like EOS and Tron, which demonstrate both the strengths and potential concerns of this consensus model. So with this understanding of DPoS, we can now consider the critical scalability challenges faced by blockchain networks. But before that, I just want to maybe have some questions related to the to advanced consensus mechanism that we just presented. So please, if you have some questions, you can note them down in the chat. If everything is good, you can also say that it's good and it's clear, so we can move on. Okay. Okay, great. I think it's clear for everyone. Okay, so in this section, we'll examine the core scalability challenges faced by blockchain networks today. So first, we have the critical issue of trade-offs, often referred to as the blockchain scalability trilemma. It's challenging to simultaneously achieve security, decentralization, and high throughput. Improvements in one area usually mean compromising another. Making balanced optimization is very difficult. Another essential challenge is finality and forking risks. When scalability is increased through quicker block creation, transaction finality may become delayed, increasing the likelihood of forks. Networks often face a difficult choice, so they need to improve scalability at the expense of secure and deterministic finality. In this section, we'll analyze a prominent layer 2 scalability solution known as optimistic rollups. Optimistic rollups significantly enhance blockchain scalability through their innovative operational mechanics. Transactions are executed off-chain and then batched and periodically posted back to the main blockchain. Importantly, transactions are presumed valid unless explicitly challenged. Central to this approach is the fraud-proof mechanism. Validators actively monitor transaction batches, identify suspicious transactions, and issue challenges when necessary. Fraud proofs play a critical role by resolving disputes, thereby ensuring network security and integrity. The key advantages of optimistic rollup include a substantial, a substantial increase in transaction throughput, enabling blockchain networks to handle significantly more transactions, dramatically reduced transaction costs, making it economically viable for broader blockchain adoption, Despite these benefits, optimistic rollups also face some limitations. There is a withdrawal latency due to mandatory dispute periods, meaning users must wait before withdrawing funds to ensure fraud detection. The effectiveness of the system relies heavily on timely and accurate fraud detection, making validator efficiency crucial. So notable use cases and implementations of optimistic rollups include projects such as Arbitrum and Optimism. Arbitrum is widely recognized as a popular Ethereum scaling solution, while Optimism provides a flexible Ethereum-compatible framework that simplifies blockchain scalability. Next, please. In this slide, we are focusing on zk-Rollups, another powerful layer 2 scalability solution offering both scalability and enhanced privacy. The technical operation of zk-Rollups involves leveraging zero-knowledge cryptographic proofs to validate transactions off-chain, significantly reducing the load on the main blockchain. Crucially, transactions undergo on-chain verification without revealing any specific transaction details, providing a unique blend of privacy and efficiency. To better understand zk rollups, it's important to grasp the concept of zero-knowledge proofs. These cryptographic methods prove the correctness of transactions without exposing transaction specifics, offering strong cryptographic guarantees for both security and privacy. zk rollups offer clear advantages, including immediate transaction finality, thereby removing waiting periods common to other scalability solutions. They also enhance privacy as transaction details remain confidential and greatly improve blockchain scalability by reducing on-chain workload. However, zk rollups also face significant implementation challenges. They require complex cryptographic setups and extensive computational resources. Additionally, specialized expertise is necessary to effectively implement and manage these solutions. Prominent projects successfully utilizing zk rollups include zk-Sync, an Ethereum layer 2 solution that emphasizes transaction privacy, and Starknet, which leverages Stark cryptographic proofs for scalable and blockchain solutions. With these layer 2 solutions understood, we now have a clearer picture of the advanced tools that enhance blockchain scalability. Okay, so we have a question. What does optimism means as a framework? I thought it was just an L2 like Arbitrum. So Optimism, the cryptocurrency that you see on CoinMarketCap, is a layer 2, and Arbitrum is absolutely also a layer 2, but they are both classified as layer 2 scalability solutions known as optimistic rollups. Okay, so I don't know if you found my answer clear or not. You can specify it again in the chat. Okay, great. Thanks for your question and interaction. In this slide, we'll explore Sidechains, an effective scalability solution designed to enhance blockchain interoperability and performance. Sidechains operate based on clear operational principles. Essentially, they are independent blockchains interoperable with the primary blockchain via bridge mechanisms. These bridges enable secure and efficient transfers of assets between the main and the sidechains. One of the primary advantages of sidechains is their ability to optimize specifically for different use cases, like gaming or decentralized finance, as we used to say, DeFi. By managing specialized tasks, sidechains significantly reduce congestion on the main chain, improving overall network efficiency. However, there are notable challenges with sidechains as well. Primarily, they rely heavily on trusted bridge mechanisms, creating potential vulnerabilities or single points of failure. Also, their security depends on separate consensus mechanisms, meaning each sidechain's safety relies on the robustness of its independent consensus. In terms of real-world implementations, we can mention very well-known layer 2 project. I think all the audience here would have heard about it at least one time, which is Polygon. So Polygon stands out as a popular multi-chain, Ethereum compatible scaling solution that effectively utilizes sidechains. Another prominent example is the Liquid network, a Bitcoin-based sidechain specifically focused on asset issuance and faster transaction settlement. Next, please. So now we'll examine other promising solutions, like state channels and their role in blockchain scalability. So state channels are another innovative off-chain solution designed to boost blockchain scalability and efficiency. State channels function based on simple yet powerful operational mechanics. Participants establish private off-chain channels that enable frequent transactions between themselves. Only the final state or outcome of these interactions is settled back onto the main blockchain, typically when the channel is closed. There are significant advantages to using state channels, such as enabling near instant transactions with minimal fees, dramatically improving the user experience, significantly reducing the main chain load, resulting in improving overall network performance and scalability. However, with the advantages come limitations, and state channels do have some important disadvantages. They introduce complexity in channel management, particularly in dispute resolution when disagreement occur. Also, liquidity can be restricted because funds need to be locked within the channels during active sessions. So when liquidity is restricted, this is a very very big limitation in my opinion. Prominent real world applications that we can mention for state channels include the widely recognized Lightning Network, a highly scalable off-chain payment solution for Bitcoin. We can also mention the Raiden network. So it's an Ethereum-based off-chain payment channel system. It is designed for rapid and low-cost transactions. So with this understanding, we can appreciate how state channels complement other scaling approaches in building more robust blockchain ecosystems. Let's take a moment and see if all the audience got what sidechains are and state channels are before moving on? Okay, thank you, Irish. Done. All clear. Okay. So in this slide, I made a comparative analysis so that you can understand more the difference between sidechains and state channels. So we'll highlight the key differences between them to help clarify when each solution is the most appropriate. So let's first look at the pros and cons. Sidechains are highly versatile and suitable for a widely variety of applications, offering flexibility through independent blockchains. However, they carry separate consensus risks, as each sidechain must maintain its own robust consensus mechanism. State channels, in contrast, are optimal for scenarios involving frequent and repetitive transactions, thanks to their low latency and minimal fees. Their primary challenges include liquidity constraints and complexity in dispute resolution. When deciding which solution to implement, use case driven decision making is crucial. So the ideal approach matches the selected scalability solution to specific transaction types, frequency of interactions, and the security requirements of the intended application. Additionally, we must consider performance implications. Sidechains typically offer broader application versatility, but may experience slightly higher latency and varied throughput based on their consensus. State channels excel in low latency, a high throughput, and cost efficiency by repetitive peer-to-peer interactions, but may introduce operational complexities. Ultimately, choosing between sidechains and state channels depends significantly on your project specific performance goals and scalability needs. In the slide, we will discuss how different consensus mechanisms significantly impact overall network performance in blockchain systems. Consensus mechanisms influence three primary performance metrics. First, latency, second, throughput, and third, security. So let's understand each one of them. Latency refers to the time required for a transaction to be confirmed and finalized. Throughput refers to how many transactions the network can process per second. And cost efficiency involves how economically viable transactions are, particularly in high volume scenarios. Comparing consensus mechanisms reveals clear differences in performance characteristics. Proof of work is known for its strong security and decentralization, but typically suffers from high latency and lower throughput due to intensive computational requirements. So that's why transactions on Bitcoin are really slow. Proof of stake significantly improves throughput and reduces latency, providing moderate transaction speeds while maintaining robust security and decentralization. PBFT excels with the fast transaction finality and deterministic outcomes, but can face challenges scaling efficiently as more nodes join the network. Delegated proof of stake achieves high throughput and very quick block times, but it introduces potential centralization risks. So, for practical understanding consider real-world examples. So as I told you, Bitcoin uses proof of work, offering robust security but slower transaction speeds. Ethereum, originally proof of work, is transitioning to proof of stake to achieve better scalability. EOS utilizes DPoS to achieve faster block production, so it faces centralization issues. Cosmos employs PBFT, providing deterministic transaction finality with speed, ideal for specific enterprise applications. So ultimately, the choice of consensus impacts not only security, but also the usability and scalability of the blockchain platform. Next, please. So in this final slide, we look ahead at the exciting future trends shaping consensus and scalability in blockchain technology. Firstly, emerging consensus algorithms are redefining blockchain performance. Avalanche, for example, introduces a leaderless consensus mechanism utilizing randomized sampling, achieving rapid finality, and significantly improving the network responsiveness. Hotstaff refines PBFT, optimizing overall performance, notably reducing communication overhead. It also enables greater scalability and efficiency. We also anticipate continued innovations in layer 2 solutions, including hybrid models that strategically combine the strengths of Rollups and sidechains, achieving the benefits of both scalability and interoperability. Advanced privacy preserving technologies increasingly integrated within layer 2 frameworks, ensuring transactions remain both secure and private, while improving overall performance. The scalability implications of these future trends are profound. Improved scalability will facilitate broader blockchain adoption across industries, making blockchain technology more accessible and practical for a variety of use cases. Enhanced interoperability standards will become increasingly critical, enabling secure, seamless cross-chain communication and interaction. So all these developments that we highlighted are exciting trajectory of blockchain scalability solutions, setting the stage for further research and innovation. Next, please. So in closing, we've outlined several research topics that represent exciting areas for deeper exploration and study in blockchain scalability and consensus. Firstly, I recommend exploring scalability solutions case studies, investigating real-world implementations such as Arbitrum, Polygon, and the Lightning Network that allows researchers to gain practical insights into scalability, performance, metrics, and adoption trends. Secondly, a comprehensive consensus mechanism performance analysis would be valuable. Comparative study of proof of work, proof of stake, PBFT, and delegated proof of stake can reveal insights into their environmental, economic, and practical impacts. Focusing on real world examples to analyze throughput and latency can guide future improvements and implementation. Lastly, researchers should closely follow future innovation and trends, investigating emerging consensus algorithms like Avalanche and Hotstaff, studying upcoming layer 2 innovations, including hybrid solution, and privacy enhancing features. Their implications on blockchain industry adoption and interoperability will be critical for anticipating the future direction of blockchain technology. So I really think these research areas will help drive blockchain advancements, shaping how consensus and scalability evolve. Okay, so if we can have now some questions maybe regarding the upcoming sessions and also about this session. So don't hesitate. If you have some questions, you can drop them in the chat or also join us on stage. Next session will be about tokenomics and governance, as usual, on Friday and hosted on our Discord server. So don't hesitate, guys, if you want to know more about next sessions or if you have questions about the content of this session. That was nice. Thanks. So you think it was all clear for you, Irosh, maybe? You have understood all the content that I presented? Okay, great. Yes. Thank you, Hadil, for coming and joining us. The presentation was well presented. Thank you. Thank you very much, Zakaria. I appreciate it. Thanks for coming and joining us today. Thanks, Zainab and Amin, for your chat. I really appreciate that. Thank you for coming. Don't hesitate, guys, if you want to know more about the 8-session program or if you have some questions regarding this session. I'm here to answer all your incomprehension. Thanks a lot, sir. Okay, thank you, Typical Liz first, for joining us. Okay, Patrick is asking, thanks a lot, sir. How do we make money out of this? Okay, so this content is only for educational purposes. I don't do financial advices, but there are many ways that you can make money with cryptocurrencies. You can buy and hold, so it's called spot. You can also trade with leverage. So it's more risky than buying and holding. What else? You can also stake cryptocurrencies to get more crypto. So we saw that in the consensus mechanism. You can also mine directly cryptocurrencies. So there are proof of work cryptocurrency that can be mined. So you produce coin, then sell them. An example is Bitcoin. We also have other proof of work cryptocurrencies such as Dogecoin or Caspa. So these cryptocurrencies can be mined. Okay. What else? You can also make money from airdrops. So we covered that in previous sessions. So you just need to complete some tasks, then you get tokens of a project that will be launched. When you get the tokens, you can then sell them, or you can also keep them if you think that their price will increase over time. So I think I covered the main ways that you can make out money of cryptocurrencies. But first, you need to do a very good research, especially if you are new to the space. So don't buy randomly and don't start randomly. Make a very good research, then you can start, okay? So thank you for being with us, Patrick. Thank you, Yusra. Yes, and if you have any final questions, you're welcome. Hadil asked me, can you please send the presentation? Of course, you will have the presentation as usual after the session. So quickly before closing, as I told you, next session would be about tokenomics and governance, but it won't be the last session of the program. We also have enterprise blockchain frameworks in our program, cross-chain interoperability and bridges that we talked about a bit in this session, but we will focus on them like atomic swap, bridging protocols such as wrapped Bitcoin, wormhole, all of that stuff. We'll also cover DeFi use cases, real-world applications and emerging trends, blockchain data privacy and compliance, and we will finish this program with smart contract security and auditing. Okay, I think we already covered 1 hour since we start. So thank you very much for joining us today on this first session of the 8-session educational journey. If you still have questions, you can ask them directly in our general chat. I'll be there to answer. And now I will let Emin close this session. Thank you very much, guys, and see you next week.
Thank you, Yusuf. Thank you for your efforts. Man, that was very, very fruitful, actually. So, guys, alright, we just broke down, let's say, consensus, mechanism, and scalability, as Yusuf was presenting to you and explaining, the nuts and bolts of how blockchain actually work under the hood, let's say. While we're here, that means we're not just watching Web3 happen. Nah. We're trying to understand it, master it, and let's not forget, use it, guys. Especially use it after each session, and that's exactly what separates the builders from the bystanders. So, as they say, practice makes perfect. So here is what's next for our sessions. If you haven't claimed your free Hashgraph header certification yet, spots are filling up fast, guys, to be honest, and this knowledge could be your launchpad. Join the Dar Blockchain community on Telegram too, and socials, guys. Follow us on socials to stay updated for every partnership, every new program, every opportunity. And let's not forget the 1 million prize pool hackathon is coming soon. You don't want to be on the sidelines when it does. Yes. So the link will be in the chat for the Hedera Hashgraph program. Also, you can check the opportunities on our Discord. We're posting every opportunity and every update there. Also check the socials, as we said. And with that, massive shout out to every single one of you who showed up today. You all make this space what it is, guys. So same time next Friday, bigger topic, and your same energy, and maybe even higher. We may have a potential guest, let's say, next week. So it's a possibility, and we will see what we can do. Till then, guys, keep building, keep learning, and keep winning. And you already are. Thank you so much, and have a great end of a week. Thank you.